All right, these are our second set of notes for this week, notes number 19. We're skipping ahead to 7-1 in the book, and that's page 415. So we are going to be learning about the Pythagorean theorem and its converse. The converse just means you're basically saying it backwards, sort of. Make sure you've got your name, date, period, and as always, 3 questions on the left when you're done with the notes and a summary at the end. You should already have your paper set up from the beginning of class, but the essential question is, how do I use the Pythagorean theorem? And again, we will have solved this in class. So we're going to learn how to use the Pythagorean theorem, which you may have learned in previous math classes. So I'm going to just go ahead and show all of this. So this says, if you know the lengths of any two sides of a right triangle. So the key thing is that this is only for right triangles. It has to have that right angle marked. So just to show you, like these triangles up here, they're not right triangles. You couldn't do the Pythagorean theorem with them. So always keep in mind it's only for right triangles. So if you know the lengths of any two sides of a right triangle, you can find the length of the third side. So here's the theorem, Theorem 65, the Pythagorean theorem. If a triangle is a right triangle, then the sum of the squares of the lengths of its legs is equal to the square of the length of the hypotenuse. So read through that a few times. Make sure you understand what it's saying. If a triangle is a right triangle, then the sum, which means to add, adding up the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. So this is what it would look like. Let me move this down a bit. It looks kind of weird, but that way you can see it all. So, and again, you guys pause it as you need to. It says if triangle ABC is a right triangle. I know it's a right triangle because of that right angle, 90-degree angle. Okay, so if it is a right triangle, then, now I'm going to get all colorful, leg 1 squared. I'll just say leg 1 is A right there. Remember that the legs join together to form the right angle and the hypotenuse is across. Leg 2 squared is right here, which is also B. And then I want a color that's really different. Green or yellow. We'll use yellow. All right, it equals the hypotenuse squared. That's the hypotenuse right there. So remember, across from the right angle is the hypotenuse. Okay, so what you really need to remember, A and B can switch. It doesn't matter which one you call A or B, the little a and the little b. But the C is always the hypotenuse. Always look for the right angle. Just draw a line straight across, and that tells you what C is. A and B don't matter. You can switch it. Because for addition, it's the same thing. It's the commutative property. You can switch the order and it doesn't matter. The other thing that I need you guys to really be aware of is that it's A squared plus B squared equals C squared. So whatever our value is for A, you have to square it. Whatever it is for B, you have to square it. And for C, you have to square it. And when you solve, that can get a little bit complicated. So it takes some practice if you're not used to it. So we're actually going to do quite a bit of practice underneath with these things. Okay, so again, look back up here if you need to see the Pythagorean theorem. It is just A squared plus B squared equals C squared. But you have to know how to use it. You need to know and understand that part. Okay, so I'm going to move it just a little bit. Okay, so these are examples of Pythagorean triples. A Pythagorean triple are 3 possible lengths of sides for a right triangle. So I'm just going to sketch it real quick. So if I make any kind of right triangle, I'm not drawing it to scale, but I'm just drawing right triangle. They have to have that little box for the right angle. I know that C is right here, and A and B can be either side, either leg, it doesn't matter. A 3, 4, 5 means that A could equal 3, B could equal 4, and C could equal 5. C, the hypotenuse, is always the largest value. So basically the way I wrote them, it's all like A, B, C, A, B, C, A, B, C, A, B, C. So these are different possibilities for the lengths of a triangle. And then we can practice right now, and just to see how the Pythagorean theorem works. Right now, these are 3 values for the 3 legs. We're not solving for a missing side, but we'll be doing that next. So this is really just going to help you understand how these numbers work and how the a squared plus b squared equals c squared works. So I can write underneath that a, b, and c. So a is 3, b is 4, c is 5. And then I would do a squared plus b squared equals c squared. And now I'm going to substitute in my values. So I'm going to do that for each one. It's going to be kind of a lot of work, but it's really important that you get this practice. So I'm going to substitute 3 squared plus 4 squared equals 5 squared. Now, if you made a mistake and you're not squaring it, think about it. What is 3 plus 4? 7. 7 doesn't equal 5. Let's see what happens when I actually square the numbers. So when you square something, it means you multiply it times itself. And as always, I'm totally fine with you guys using a calculator. So I'm pulling up my calculator to show you guys. When I just look at my phone calculator like this, it doesn't have the square, but I could do 3 times 3. I mean, I know that's 9. So I could do it like that, but you can turn your your phone sideways if yours is like mine, and then you get more buttons, and it's it's that one, the x squared. So I could do 3 and then that button. So it's just up to you how you do it. And then we will maybe have to do the square roots. So I'm noticing that that button's here too. So we need the squared, and then later we might need the square root. Okay, so anyways, I think this one's pretty easy. I'm not going to use my calculator. 3 squared is 9. 4 squared is 4 times 4 is 16. 5 squared is 25. And then I have to add 9 plus 16. Since I have all the values I'm not solving, I'm checking. I'm checking equality to make sure it is true. So 9 plus 16 is 25. 25 equals 25. So yeah, I'm verifying that it is a Pythagorean triple and that it does work. Notice that if I had changed any one of these numbers, just one of them, this would not be equal. If it was a 2 instead of a 3, it would be 2 squared, and then it would be 4, and that would be 20, and 20 would not equal 25. So it has to be like this special group of 3 numbers. All right, so let's try that with the next ones. I'm going to go quicker. It's going to go A, B, C. The biggest number is always C. And then I'm going to have A squared plus B squared equals C squared. Substitute now. 5 squared plus 12 squared equals 13 squared. So when I square each value, it would be 25. 12 squared is 144, 13 squared is 169, and then I combine 25 and 144. I'm going to double check on my calculator, and that does equal 169. So that does work. It is equal. So let's just go through and check the rest. So just to practice, remember A, B, C. C has to be the largest. I'm going to just go straight into 8 squared plus 15 squared equals 17 squared. I'm using the same thing, A squared plus B squared equals C squared. 8 squared is 64. I don't know 15, so I'm going to do 15 times 15. Or if you have the square button, you could use that. It's 225, and then 17 squared is 17 times 17, 289. And then I'm going to add together 64 plus 225. So I hope you guys are doing the calculations too, because you really do need to practice. So that works out too. So these are all working out with the Pythagorean theorem. Again, if these were not possible side lengths for a right triangle, this would not be equal. Okay, so these ones should all work. and we're just verifying. So you write a, b, and c, 7 squared plus 24 squared. So as you can see, the largest number is the number that's alone on the other side of the equal sign. And then you square them. 7 squared is 49. 24 squared is 576. And then 25 squared, whoops, is 625. Okay, and then I just have to combine those, and I'm going to double check it. So I'm adding it in my calculator, and it does equal 625. Okay, so check. So all of these, I don't know, all these three numbers each time, there are three possible side lengths of a triangle. So like how I was showing here for the 3, 4, 5, it could be 5, 12, and 13, 8, 15, and 17, 7, 24, and 25, and there's a bunch of other different possibilities, okay? You could just make up numbers and then solve for the missing one, and it would work out, okay? But these are called Pythagorean triples. I'm going to highlight that. So there are three possible lengths for sides of a right triangle. All right, so let's move on to the next page. Okay. Here's the converse of the Pythagorean theorem. It's pretty short, but pause if you need to copy that down. Focus it again. Okay. So what it says is it's backwards basically. So if a squared plus b squared equals c squared, then a triangle ABC is a right triangle. So let's say instead of finding a missing side length, we have three side lengths and it's asking, hey, is this a right triangle? You would have to test it. The longest side length would always be C, and then you just plug in the other two numbers for A and B. So we're going to practice both of these things right now just in the notes. And there won't be book work. We'll just do the work right here to practice, and then you will have an alex.com assignment. Okay, so pause if you need to, but I'm going to just keep going so that way you can move at your own pace. So find the missing side of a right triangle. That's using the Pythagorean theorem. So I'm going to write it down. A squared plus b squared equals c squared. C is across from the right angle. So I'm going to put an X for C. Okay, the other two sides, it does not matter. I could switch the A and the B. I'll just say that A is 8 and B is 15, but it really doesn't matter. You could switch them. The one that matters is the C. C has to be across from the right angle. Find the right angle and go across from it. Okay, so I just have to plug in my values. So A is 8, 8 squared. B is 15, so 15 squared. And then C is X, X squared. And then I do my calculations. 8 squared is 64. 15 squared is 225. That equals X squared. I have to combine those numbers together. So 225 plus 64. Maybe I should show you what I'm doing on the calculator. Okay, so I've got the 289. I'm going to run out of space though. Okay, I can write right here. So 289 equals x squared. This is the part that I haven't had a chance to show you yet. What you need to do is that's not telling you the side length of x, it's telling you x squared is 289. So we need to undo the square by taking the square root. So when I take the square root, it cancels out the x squared, and I'm out of space, so I have to write it here. So x is still on the right, x equals. So on the calculator, this is where I was saying you'll have to use the square root button. There, you can kind of see. So I have to press, so that's not going to come out right. I'm going to clear it. I have to press on my calculator the square root button first, and then 289. So test and make sure on whatever calculator you're using that it comes out correctly to get 17. So x equals 17. So that would mean on this triangle that this side is 17, and I would check and make sure, using common sense, does that make sense? It shouldn't be negative, and it should be the longest side, and it's not too high. Like 289 would have been huge. That would have been way too big of a number. So 17 definitely makes sense when I'm looking at this side is 8, that side's 15, and then 17 here. Okay, so let's do some more examples. All right, it does take a lot of practice, so we'll do all of these, and then the alex.com is very important for you to do. So the first thing you do, draw your line across to the hypotenuse, and that would be C. The other ones can be A and B. So I'm going to write down A squared plus B squared equals C squared and plug in my values that I know. A is going to be X this time, and B will be 4, 4 squared. C is now 7, 7 squared. So you can tell this one's going to come out a little bit differently than the last one. So I'll show you how to do this. Keep the X as X squared, but 4 squared, go ahead and calculate it like order of operations. First you do parentheses and then exponents. So that's 16. 7 squared is 49. What I need to do is get the X alone. Even though it's X squared, I need to isolate it on one side. So I subtract 16, and I'm going to have to continue right up here. So then I get X squared alone on the left because I subtracted 16. 49 minus 16 is 33. Let me double check that. Yeah, 33. That's just weird because it's going to come out to be a decimal. So this is how it's going to come out on, it almost fits. This is how it'll come out when we're working on alex.com too. It'll tell you round your answer to the nearest hundredth. So I'll show you guys what that would be like. So we'll do the same thing. We'll round our answer to the nearest hundredth. So I have to now square root both sides. Oops, because that undoes the square. I want to undo the square. So I square root both sides. X is now just X, but I have to square root the 33. So I'm going to press the square root button, 33 on the inside, and you can see my answer. It's an irrational number. It keeps going forever and ever and ever. There's not a pattern. So I do need to round to the hundredths. So after the decimal, it goes tenths, hundredths, thousandths. So hundredths is that first 4 right there. So again, tenths and then hundredths. I look to the right. If it's 5 or above, I round up. I would make the 4 into a 5. If it's below a 5, I keep it the same, and then I just don't write everything after. So it's 7.44, so that 4 keeps the 4 the same. 5.74 is my answer. And since I'm rounding, we're supposed to do little wiggly lines to mean approximately. So 5.74. And that would be my side length. And again, like I told you guys, let's just make sure using common sense that this makes sense. It's not negative. It's smaller than the hypotenuse, which it should be. If I thought it was 33, that wouldn't make sense because the hypotenuse should be the longest side. So X is approximately equal to 5.74. All right, so we'll just keep going. We're going to do more practice. Okay, number 3 is a problem I got out of the book, but I don't think you'll have a problem like it on alex.com. They'll be more like number 1 and 2, but this is still good practice. So I'm still going to be thinking A squared plus B squared equals C squared. Find your C first. It's across from the right angle. The other two sides are A and B. So now I'm substituting X squared plus X squared equals 6 squared. So you can see I just substituted X and then 6. So this one's different because I can actually combine these like terms. 1x squared plus 1x squared is 2x squared. And then 6 squared is 36. So I can't just square root both sides. I need to divide by 2 first. So like up here, I would like subtract to get a number away. Here I need to divide to get rid of that 2. And then I have to rewrite it over here. So now I have x squared alone. 36 divided by 2 is 19. Oh, let me double check. 18. Yeah, 18. Okay. All right, and then just like the other ones, once I have it to this point, I would square root both sides. 18 is not a perfect square, so then I have to use the calculator. I'll show you guys again how to do that. So I press the square root button. Whoops, that's not it. Okay, the square root button, and then I put 18, and I'm going to round to the nearest hundredth. So it's 4.242. Don't worry about what's after the 2. 4.242. Since that the number on the right is a 2, I keep this 4 the same. So I don't have to round up. I keep it the same. 4.24 is my approximate answer. So I'm going to make it wiggly lines again. 4.24. So check and see if that makes sense. If one side's 4.24 and the other's 4.24, and then the hypotenuse is 6, that makes sense. It's a possible answer. Also keep in mind that this would be an isosceles right triangle. So you could even mark the sides congruent if you wanted to, and then I would know that these angles are congruent. Just remember that we did learn about isosceles triangles, and this is an isosceles right triangle. Okay, next one. As we've been doing, just get used to this. A squared plus B squared equals C squared. Start with C, go across from the right angle. C is going to be X. The A and the B don't matter. I could make A be 35 and B is 12. And then I'm just going to substitute and start solving. So I'm saying A is 35, 35 squared, plus B is 12, 12 squared. C is X, X squared. Okay, and then I use my calculator because I don't know what 35 squared is. It's 1,225. 12 squared is 144, and that equals x squared. And then I combine my 1,225 plus 144. I'm going to write it up here. 1,369 equals x squared. So that's not x, it's x squared, so I need to square root. Cancel the square with the square root. They're inverse operations, they cancel out. And then I'll show you on the calculator. Move it a little so you guys can see. Oops, that's the wrong way. Okay, like that. Okay, so I'm taking the square root of 1,369. Oh, it comes out perfectly to 37. I would not have known that. So that equals 37. X equals 37. And then I check. I always like to verify my answer. Does it make sense? If I have one side that's 12, another side that's 35, and then my hypotenuse is 37, that does make sense. It's not negative and it's the biggest side. It should be the longest. So, okay, so real quick, we're going to do these last ones. Are these triangles right triangles? Notice that it's not labeled with the right angle on any of them. There we go. So we have to check, kind of like I did with those Pythagorean triples, but now some of these are not going to work out. So check with a squared plus b squared equals c squared. C needs to be your largest number. If you can't tell where the right angle is supposed to be, look for the largest number. That's going to be C. So here I see the 50 will be my C. The other ones don't matter. Right, a squared plus b squared equals c squared. Substitute in your side lengths, and we will definitely be using a calculator. Let me move this so we can see it a little better, because I'm going to show it in the calculator. Okay, so I don't know. I'm going to just zoom out a little. Okay. So I'm trying to show you a quick way to do this. So I'm going to do 48 squared plus 16 squared. Oops. Make sure you're writing the right things. Okay. And that comes out to 2,560. 2,560. And then I just have to see, okay, what is 50 squared? Sorry, I'm covering it up. Okay, so 50 squared is 2,500. So it doesn't look like that's going to work out. I'm just going to double check that in my calculator. 48 times 48 plus 16 times 16. Yeah, it doesn't work out. So I tried it again one more time just to make sure. 2,560 is what we get on the left-hand side. 50 squared is 2,500, so that is not equal, so not a right triangle. If it is equal, it is a right triangle. If it's not equal, not a right triangle. Pretty easy to tell which one it is. Okay, so let's try the next one. Again, the main thing is find which side is the C. If it's a right triangle, it's the hypotenuse. So the longest side is always C. The other two don't matter. A squared plus B squared equals C squared. A I'm going to put as 20, so do 20 squared. B 19, 19 squared, and C will be 28 squared. So again, I'm going to try this. I'm checking on my calculator. I'm going to see if it works out. So 20 squared plus 19 squared. I get 761. Now I'm checking, does that equal 28 squared? 784. Oh, it doesn't come out to be the same. So that is not equal. Not a right triangle. All right. So now I'm going to try the last one. Maybe this one is a right triangle. So again, we're checking with a squared plus b squared equals c squared. The longest side will be c, and then the other ones will be a and b. A squared plus b squared equals c squared, and then substitute 33 squared plus 56 squared equals 65 squared. Go to the calculator. I'm going to cover that up for a second. 33 squared plus 56 squared. 4,225. I'm checking to see, does that equal 65 squared? That one does work out. Okay. So now you can see those are equal. So this one is yes. It is a right triangle. Okay, so these notes were a little bit long, sorry, but it's really important that we get this practice. Even practice it again on your own if you haven't had a chance to try these in the calculator. You need to know how to use the square button and the square root button, like up above. You need to know how to do that. Make sure you've got your 3 questions on the left and a summary at the end. These notes will be due on Friday. All right, so make sure you guys do your alex.com assignment and just be ready to turn everything in at the end of the week.